episode of learning trigonometric identities. In this video, we will be able to discuss trigonometric function of tangent and graph its functions. So sketch the graph of the function y is equal to tan 5x for the interval 0 degrees less than or equal to x less than or equal to 72 degrees. The function has no amplitude. Remember, the tangent functions do not have amplitude because these functions do not have a maximum nor a minimum y value. Next, we have the frequency of 5. For the period, since the function is tangent, so we use the formula t is equals to pi over the absolute value of b. So we substitute 5 and we have t is equals to pi over 5. Further on, we try to convert it into its degree measure, so we multiply it by 180 and we have 36 degrees. Next is we get the x values that we can use to easily sketch the graph. Let's start with x sub 1, that is 0 degrees. X sub 2 is equal to t over 4, and we will have 36 degrees over 4. And we have x sub 2 is equal to 9 degrees. X sub 3 is equal to t over 2. Again, substitute 36 degrees, so we have x sub 3 is equal to 18 degrees. Next, x sub 4 is equal to 3t over 4, so we will have 3 times 36 degrees over 4. That will give us 27 degrees. Lastly, x sub 5 is equal to t, which is 36 degrees. We now have the x values to be used on our graph. If you notice, we extended up to 72 degrees since we have the given interval. The x values lies in a pattern added by 9, so 36 degrees plus 9 is equal to 45 degrees and so on. To solve the value of the corresponding y value, we have this function y is equal to tan 5x at x is equal to 45 degrees. Substitute y is equal to tan 5x for 45 degrees, then we have y is equal to tan 5 times 45 degrees. That is equal to y is equal to tan 225 degrees. That coordinates the intersection point on negative square root of 2 over 2 and negative 2 over 2. If you look at the units of the circle. Following this point, define tangent theta is equal to y over x, where x cannot be equal to 0. Again, y is equal to 1 times negative square root of 2 over 2 over negative square root of 2 over 2, and we have 1. So, as you can see on the graph, 9 degrees is 1, 18 lies undefined, and so on.
Let us try to solve y equals 2 tangent 3x for the interval 0 degree less than or equal x less than or equal 90 degree. Again, the function has no amplitude, and we have the frequency of 3. Solve for the period, and we have t equals pi over 3 multiplied by 180, that is equal to 60 degree. We then further solve for the x sub values. We have x sub 1 equals 0 degree, x sub 2 equals 15 degree, x sub 3 equals 30 degree, x sub 4 equals 45 degree, x sub 5 equals to 60 degree. Solve for the y values. Again, simply substitute y equals 2 tangent 3x, where x equals to 15 degree. And we have our table of values and proceed to sketch the graph. We have 15 and 2, 30 comes undefined, and so on.
Moving on to our third problem, a plane flying at an altitude of 10 km over level ground will pass directly over a radar station. Let t be the ground distance from the antenna to a point directly under the plane. Let x represent the angle formed from the vertical at the radar station to the plane. Write d as a function of x and graph the function over the interval x is greater than or equal to 0 degrees but lesser than or equal to pi over 2. So as you can see, we have a worded problem involving trigonometric functions. So We would have a 10-kilometer altitude here and our flying plane here. As for our D, this would be our ground distance, and of course, the radar station under the plane. From the vertical up to our plane forms an angle that represents our x. Notice how we have an angle with the opposite side over the adjacent side. When we take a look back, this represents as tangent theta is equal to opposite over adjacent. Simply, tan x is equal to the opposite side, which is d, over the adjacent side, which is 10. If we want to write d as a function of x, we have to isolate d, and this would be d is equal to multiply both sides by 10, and we have d is equal to 10 tan x. Then we proceed to sketch its graph. We can see that it passes through 0 and 10 units up, or simply a vertical shift of 10 with an asymptote of pi over 2 given by its interval.